everyone, welcome back to Anu's Chem Corner. I am Anu and today we are going to discuss something super helpful as we approach the AP Chemistry exam. I know if you are feeling comfortable with some topic, but the questions are really tricky, right? AP MCQ questions are really tricky. So sometimes you struggle with how to deal or how to approach those kind of problems. So if you struggle the same, this video is for you. Let's crack and let's see how to approach those kind of problem and how to read the problem like in words. Some clues are maybe lies in that questions. So grab your notebook and let's dive into get you prepared for the big day. Don't forget to hit the like button, share, subscribe, and let me know in comment if you have got any questions or topic you want me to cover next. Let's do this. So let's do this one. So first question, you can read the question and pause the video and try to answer it, and then you check with my answer. Okay. So first question, NH3 liquid is turning to NH3 gas and the corresponding delta H is given, vaporization and enthalpy of vaporization is given, and NH3 has a boiling point of 239. Which of the following values would be the closest to the entropy of vaporization for NH3? So what we need is entropy. So it's a thermochemistry, right? It's a question from thermochemistry. So delta S we need. What they were given, delta H is given, temperature is given. Is there any relationship? Did you study with the delta H and delta S and temperature? Yes, you know that delta G is equal to delta H minus T delta S. Okay, so delta H is given like 23.9 kilojoule per mole. The units are also very important. And the temperature is given like 239 Kelvin. And yeah, delta S we need. What about delta G? If you know the delta G, then only we can do this problem, right? So what about the delta G? They were not given any delta G, but what may be? See, it's boiling point. They were talking about some boiling, vaporization, isn't it? So any phase transition or any equilibrium state, you can say delta G will be 0. Okay. Now what we need? Just do the max. Correct? So delta S you can calculate simply. And also be careful. See, this is kilojoule and what we need is in joule. Okay. So what is delta S then? Yes, 23.9 kilojoule per mole divided by 2239 Kelvin. Okay, but make sure kilojoule have to convert to joule. 1 kilojoule is equal to 1000 joule. Okay, so that's all. So while you're doing so, you can get the answer. So the answer is B. Did you get the answer? Okay. Then the second question. Again, substance is given, boiling point is given, something related to boiling point. Okay, benzene and C2H5OH, ethyl alcohol is given, their corresponding boiling point. Okay, given the data in the table above, which substance would have a lower vapor pressure at 298 Kelvin and why? C6H6 due to its more polarizable electron cloud, due to its permanent dipole, and C2H5OH due to its hydrogen bonding, C2H5OH due to its presence of lone pairs on oxygens. Okay, so here also what's the principle? Like which chapter, which topic is doing with this thing? You know that IMF, correct? We know that IMF. What is the relationship between the IMF? If IMF increases, boiling point increases, melting point increases, surface tension increases, correct? But what about vapor pressure? Vapor pressure decreases, correct? Vapor pressure means pressure exerted by the gas. So who is exerting the pressure? Like, if vapors are there, more will be there exerting pressure. So IMF is higher means higher IMF, intermolecular force is there. Is it easy to vaporize? Correct. If see this is a molecule, if they are strongly attracted to each other, the IMF is higher, then it's very hard to do with a gaseous form. You need to put a very high amount of energy in order to make it a gaseous form. So if vapors are low, their exerting pressure is also low, isn't it? So that's why higher the IMF, then vapors will be low. At that time, their exerting pressure, vapor pressure is also low. So the question is which one having low vapor pressure means which one having high IMF. That's the question. So maybe when you think this molecule, you may think like, see, this is OH, hydrogen bonds are there. So definitely C2H5OH have higher IMF like that you may think. But see the boiling point. Boiling point is a direct evidence. See the boiling point. If C2H5OH IMF is higher, then definitely boiling point of C2H5OH have to be higher. But you can see C6H6 have a higher boiling point. Okay. C6H6 have a higher boiling point, so definitely IMF will be higher for C6H6. Okay, so definitely their vapor pressure should be lower. Okay, why? Why is it so? Like C6H6, like a hydrocarbon, it's even non-polar. Then how it's possible? You may think like that. How hydrogen bond can like LDF? If it's a non-polar molecule, it's LDF, right? If this one is a non-polar, the IMF is LDF. How LDF can beat the hydrogen bond? We are always telling like hydrogen bond higher than dipole-dipole interaction than LDF. See, that point is you can apply only with a similar molar mass. If the molar mass is not similar, you can't do that one. Okay, so here the molar mass is drastically different. Like C6H6 have a high molar mass. High molar mass means high electron density is there. High electron density is there means they can easily polarizable. Okay, easily polarizable means that's how LDF work. If high LDF will be there. So that's why higher molar mass means higher will be the LDF. Don't underestimate LDF. Correct? So you have to answer like high boiling point C6H6. So definitely they have lower vapor pressure. So A or B, which is the correct option? Yes. A option you can do choose correctly, correct? Because B option is completely wrong. They don't have permanent lack of permanent dipole is okay. So which means they are like opposing effect. If due to not permanent dipole means they are non-polar. Okay, how non-polar IMF now becomes the dominant? That you have to answer. So the answer to the question is A. Correct? The B is just telling a fact, but that's not the reason for the low vapor pressure. Low vapor pressure means higher IMF. So why even a not that lack of permanent dipoles are there, then how it's again a high IMF is present in C6H6. That's the point. Okay, so option A you can choose the correct one. Okay, next. Question number 3. Which of the following 1 molar aqueous solution would experience the highest percentage of ionization? Okay, which means which one can give higher? See, all of them are HClO, HClO2, HBRO, HBRO2. Okay, so which one is highest percentage of ionization? Which means which one can donate high H plus? Okay, dissociation like H, they will dissociate like H plus plus and Cl. Oh, these all are acid, right? These all are weak acid. So how, which one is more stronger acid? That's they were asking. They were not given any Ka value, so we can't use any Ka value here. Then what to do? Okay, so these kind of thing how we are doing, which one is like, which one deprotonated form is more stable? Okay, which one deprotonated form? So suppose they were donate this H plus, see they will donate H plus, Cl minus is formed. Okay, so if Cl minus O minus is stable, then HClO will easy to donate electron, donate H plus. Okay, ClO minus is called deprotonated form. If the deprotonated form is stable, then they are okay with that one. They are ready to give that H plus. Their percentage will be higher. So you have to think which of the following deprotonated form is more stable, whether it is ClO minus or ClO2 minus or BRO minus or BRO2 minus. So how do you tell that one? You can think about the electron negativity. See, like deprotonated form can be stable whenever there is a charge concentration, it will be destable. Okay, if any charge stabilization is there, charge concentration is there, which means that is destable, like that is not that much of stable, that is unstable. Okay, correct. So if, so for example, in Cl minus there is a charge concentration like minus, but what about the nature of Cl? Cl is electronegative, so they drag electron density to themselves. So that negative charge concentrated here is somewhat distributing now. So which one can do more distribution? Which one can do more distribution? That will be the stable structure. The other one will be unstable. Okay. So see, for example, here Cl or Br, which one is more electronegative? Definitely Cl. Cl is the more electronegative. So Cl drag more negative charge. Got it? Here also Br or Cl minus. That's a comparison. So you can say Cl drag more. Okay. If it's so ClO or ClO2 minus, which is more stable? Yes, ClO2 minus. Why? Because there is not only dragging the Cl, oxygen can also drag. Correct? Oxygen is also more electronegative, like electronegative. So they are dragging more. This is how it's work. Okay, so very less charge distribution, like charge concentration, sorry, very less charge contribution, charge concentration, that will be the stable structure. Okay, so here more oxygen, more will be the stabilization. Clear? So O2 or Br2, like HClO2 or HBr2. At that time you can think about Cl or Br. Cl is again more electronegative. Okay, so you can choose HClO2 is most like higher acidity will be there, like higher percentage dissociation will be there, more stronger acid will be there. Okay, what's the reason? First you can think about oxygen number. If more oxygen, more will be this dragging capacity. Similarly, most electronegative atom like chlorine, bromine, like that, which one is more electronegative atom? So more electronegative atom, if it attached more, more will be the charge distribution. That will be the stable structure. Okay, so that's it. Okay. So next one, they were given like atomic mass and relative abundance, like mass spectrum. They were given. Okay. And the question is based on the mass spectrum shown above, which of the following can be concluded about zirconium? Okay, zirconium. Let's move on to the first option. The most common charge on zirconium ion is +2. Zirconium nuclei can have different number of protons. Average atomic mass of zirconium atom is 90 AMU. The most common isotope of zirconium has 50 neutron. What do you think? First one, most common charge on zirconium ion is +2. Is it possible? Can we say by using a mass spectroscope? Sorry, mass spectroscopy? No. By using mass spectroscopy, we can't say which one, which ion is like how many electron they have to donate or what's their tendency, like that. We can't say anything. Mass spectroscopy is just a different atomic like isotopes present, right? They were shown just different isotopes and their natural abundance. Nothing to say with their electron nature. So that's wrong. Zirconium nuclei can have different number of protons. Definitely not, right? All of the nuclei, like all of the nuclei in the same element will be same, like same in the respect to number of proton. So that is not possible. Only different number of neutrons are possible, correct? Okay. Average atomic mass of zirconium atom is 90 AMU. Can we say like that? See, here 50 percentage of 90 is there. Some 10, 11 percentage is 91 is there. So you have to take the mass like weighted average method. Correct? How do you calculate the atomic mass? You have to consider 90 times their natural abundance. For example, if I am taking like 50, 50 over 100 plus 91 times 10 percentage, I'm taking 10 over 100 plus 92, some 80 I can take, right? 18 over 100. Okay, plus Then 94 is there. 94 times how much? Again, I am taking some 80 over 100 plus 96 times the remaining number. Whatever be the remaining number, you can write some 5 or something like that. Correct? I'm just taking 5. I don't know. I just didn't count the number. In that way, I'm just supposing it's 5. So 5 over or 4 maybe. Like this is 18, this is 18. So maybe 4. Okay, 4 over 100 like that I can take. So this whole calculation will give the average atomic mass. Okay, so otherwise you can't say it is just 90. Okay, the most common isotope of zirconium has 50 neutron. So see the most common isotope. Which is the most common isotope? Yes, the highest like height is this one. So 50 percentage. Okay, that's the most common isotope. That have 90. What is this 90? 90 is the mass number. What is meant by mass number? Mass number is actually the number of proton and number of neutron. Correct? Number of proton we can get from the periodic table. Number of proton of zirconium is 40. Okay, this mass number is 90. So yes, definitely number of neutron should be 50 then. So that option is correct. So you can go with that option. Clear? Okay. Then the next question, as shown above, four identical containers hold the same number of moles of four different gases at 298 Kelvin. Okay, so identical container hold the same number of moles. If ideal behavior is not assumed, in which container would be pressure be the lowest? Okay, so we know that PV is equal to nRT is actually ideal gas equation. So according to this one, if volume is constant, number of moles constant, temperature is constant, then pressure also should be constant. All of them have same pressure if it were ideal gas. But here they were telling it's not an ideal gas. So we don't want to follow this equation. So pressure will be different. If it's so, which one having lowest pressure? That's they were asking. Is it H2O, CH4, neon or helium? Okay. So here what may be the concept we need to apply? You may be guessed. IMF. Again, IMF plays the role. Okay. So IMF, what we can talk about, like higher the IMF, what happened? Which one is higher the IMF? So helium is an like just helium means LDF, right? Okay, neon is again nonpolar LDF. CH4 is also nonpolar, so LDF. And H2O is hydrogen bond, and all of them is similar molar mass. So you can and this one is even lower molar mass. Okay, so you can consider H2O have higher IMF. So if it's what's the thing, higher the IMF, what happened? See, if higher the IMF, like pressure means, what do you mean by pressure? Pressure means the force exerted by this molecule to the walls of the container, right? See, this gas molecule will exert a force to the walls of the container. That force per unit area is what we call the pressure. Okay. So if this push or this pull is actually higher the IMF, then what happen? This will attract more. Okay, the molecule attraction will be higher, so it's very less chance to get a force, or very less force they will act with the walls of the container, isn't it? They will act a very less force with the walls of the container, because these molecules are they were already attracted each other. Got it? If molecule attraction is higher, see, it's just like you can think about like a okay, pulling effect. This molecule is pulled by this molecule, correct? So that their force acting on these walls of the container will be lower, so pressure will be lower. So what my point is, higher the IMF, again lower will be the pressure. Okay, so H2O having higher IMF, so H2O will be the lower vapor pressure, lower pressure. Got it? That's it. Again, then 6 to 8, this is the like data. The below unbalanced reaction occurs when the solution of potassium dichromate is titrated into the solution containing aqueous Fe2 plus ion. Okay, anyway, they were given some reaction. Question is which species is being oxidized and which is being reduced. Okay. First of all, this is not balanced, but yeah, for getting the oxidation and reduction, we don't need to balance it. Let's see. Let's see the reduction oxidation number. Okay, Fe2 plus 2 plus is the oxidation state. And what about the product? Yes, product have Fe3 plus. Okay, so oxidation number increased. Definitely Fe will be the oxidation species. So B or D. Okay, then hydrogen is H plus and the product also in H2 also hydrogen is H plus, so definitely chromium, correct? So Cr2O7, Cr2O7 2 minus will be the reduced species. If you have any doubt, you can check the oxidation number. So this is plus 6 and this is plus 3. Yeah, oxidation number decreased. So which option? Yes, D option. Okay, that's all. Then what must be the coefficient in front of the ion on both sides of the reaction be in order to balance the reaction? Oh, now you can balance the reaction. Okay. So Fe2 plus is turned to Cr2O7 2 minus. Oh, they were already partially balanced. We just need the electron balancing. Correct? For example, what they were asking is Fe2 plus to Fe3 plus. Okay. But what about this hydrogen I'm omitting because they are not, nothing is happening. So you just think about the half reaction like Cr2O7, 2 minus is turning to 2Cr3 plus. So see how many electrons are difference are there? Plus 6 is turning to plus 3. Correct? Which means 3 electron difference is there, but for one chromium. Here two chromiums are there. So altogether there are 6 electrons are involved. Isn't it? There are 6 electrons are involved. So that how the 6 electron? Fe2 plus is turning to Fe3 plus by donating 1 electron. What we need? We need 6 electrons. So have to multiply with a 6. That's how we need to balance the redox reaction. Okay, first we can take the half reaction like Fe2 plus to Fe3 plus, and the other one is Cr2O7 2 minus to Cr3 plus, but 2 Cr3 plus, correct? So each chromium 3 electrons are involved, 6 plus plus 6 to plus 3. So 2 chromium 6 electrons are involved, and we need to maintain like make the electrons same. That's why you can multiply with a 6. So that's all. So which means 6 should be the coefficient. Isn't it? Okay, the option is there. D will be the option. Clear? Okay. And the last question, like not the last, last from the this 6 to 8. Okay, by using the same data. Okay, which of the following correspond to the electronic configuration of Fe3 plus? Okay, do you remember Fe is, what is the Fe? It's argon. Okay, and 4s2 3d6. 3d6 actually the Fe. So Fe3 plus means, is it 3d3? No. It's not about 3d3. Electron has to lose from the valence shell. Valence shell means highest n value is what we call the valence shell. So electron first they have to lose from the highest number of n, which means that's the valence shell. This is 4s. 4s electron has to lose first. So Fe3 plus means that is Ar, and this electron will go, and again one more electron have to lose because Fe3 plus, so 3d5. So which option? Yes, B option. Okay. So the next question is which of the below molecule would have no dipole moment? Okay. So no dipole moment. So the concept is chemical bonding, correct? Okay. We studied that no dipole moment means, what do you mean by no dipole moment? Polar. No dipole moment means non-polar. Dipole moment is there, which means it's polar. Okay. So this is non-polar. They were asking which is the following is non-polar. So what we studied? We know that central atom with the lone pair, correct? Central atom, if it have a lone pair with the lone pair, is usually polar, correct? That's the one criteria. Usually, generally, it's like that. Okay. And the second one, asymmetric molecule. Asymmetric molecule is also bipolar. So these are the two conditions. If these are the thing, it should be polar. Here, every molecule have lone pair, like central atom have lone pair, isn't it? See, here lone pairs are there, here lone pairs are there, here it's there. So that first thing we can't consider, isn't it? By looking central atom with the lone pair, every molecule is have lone pair, so which doesn't mean everything is polar. So let's see this asymmetry. Next one. So which one is asymmetry? You know what is the shape of this molecule? See the first one central atom with the what kind of category, what type of molecule is this one? Yes, central atom with a 3 bond pair and 2 lone pair. So we can say it's an AB3E2 type. AB3E2 type means totally there are 5 electron clouds, so trigonal bipyramidal, but 2 electrons, so which means it's T shape. Correct? See, it's look like a T shape. So T shape means it's asymmetric structure. Correct? Yes. So it's not, it's a polar molecule. Okay. Then what about this one? Here also, what is this kind? A, B, 4 and E1. Correct? 1, 2, 3, 4, 5. Sorry, AB 5 and 1. So one lone pair is there, which means octahedral is the electron geometry, but the shape is called a square pyramidal. Square pyramidal. That is also what? Asymmetric structure. So it is also polar. Then what about this structure? This is AB4E2, which means square planar. Correct? Again, the electron geometry is octahedral, but the shape is square planar. Okay. So what about their symmetry? It's a square planar symmetry, which means it's symmetrical, right? So this one will be non-polar. And the next one, 4 and 5. So AB4 and E1. 5, altogether 5 electron cloud are there. So the shape will be trigonal bipyramidal, like electron geometry is trigonal bipyramidal. But one of the thing is occupied by electron, which means it's a seesaw shape. Okay, so that is also asymmetrical. So it's also polar. So which one is non-polar? Square planar molecule. This is what? Symmetrical molecule. Okay, so see, just 4 bond pair and 2 lone pair. Okay, so that's how we have to look at that one. Then second one, they were given some data. Okay, ABCD and conductivity as solid, conductivity as liquid, conductivity in water. Okay, data considering the conductivity of 4 different substances in their various phase is given in the table above. Of the 4 options, which substance is most likely to be NaCl? Okay, so we are searching for NaCl. Which one, which property shows NaCl? If NaCl is it conductive as solid? Is it conductive as liquid? Is it conductive in water? That's the question. Okay, so we know that it's again chemical bonding concept. We know that NaCl is an ionic solid, right? Because it's a metal and non-metal is there. So it is ionic solid. So for an ionic solid, definitely it's not having a conductivity in solid state. Metal have conductivity in solid state. Correct? So definitely this is law. So option A is wrong. Okay. Then what we studied about ionic solid, it is conductive in melted form, like in liquid form, and also it is conductive in solution. If they were dissociated in like water, like in water they will dissociate into its ion, at that time also they will conduct electricity. So what happened? Which option? B may be the correct one, isn't it? Because this is law, so that will not be the answer. So B. So substance B is NaCl. Alright, that's all about today's video. If you have any doubt, please drop a comment below. And yeah, definitely if you found this video helpful, please do like and share and support. And don't forget to subscribe to Sanu's Chem Corner. Bye. Thanks for watching.